Assalamualaikum and hi, we are from Group 2 F4 CS1115C. In this video, we are going to present queuing theory project that we observed at 99 SPEEDMART. First of all, I will introduce our group member. Our group consists of 4 people, which is Nur Aqilah Aina, Nur Adriana, Nur Amira, and me, Nurul. And we will continue with our introduction.
Introduction. For the location of 99 SPEEDMART is at ground floor number 3A and 5, Jalan Walagonia 1, Taman University Walagonia, 35,400, Tapah Perak. 99 SPEEDMART operation time is from 10 AM until 10 PM. We start our observation at the peak hours, which is from 5 PM to 6 PM. During our observation, we found that the number of servers is 2. As we can see, there are 4 pictures that related to 99 SPEEDMART. On the first picture shows that the service facility characteristic that 99 SPEEDMART use is multi-server, multi-line and single phase. For the second picture shows that the server is serving the customer at the counter. The third photo shows that the customer are queuing and waiting for their turn to be served. The last picture shows that the 99 SPEEDMART premise.
I will continue the presentation with the characteristic of queuing system. We have 3 characteristics, which are arrival, waiting line, and service facility. Firstly, the arrival characteristic. The size of the calling population, which is either finite or infinite. 99 SPEEDMART have an infinite calling population because there is a large number of potential customers. There is always possible for one more customer to arrive and be served. Next, the pattern of arrival at the system, which is our lambda, is 56 customers per hour. Then, the behavior of the arrival exists, which is patient customers, where all the customers are willing to wait in the queue until they are being served. Next, let's take a look at the waiting line characteristic. The length of line is unlimited, while the queue discipline is first in, first out, which is the customer who comes first will get to be served first. We will continue with the service facility characteristic, the configuration of the service system. For the number of channels of 99 SPEEDMART is a multi-channel system because they have 2 counters for customers to be served. In addition, the number of phase of 99 SPEEDMART is a single phase system where the customer only receive the service at only one counter and then they will exit the system. Next, the pattern of service time, which is our mu, follow the exponential distribution, which is 34 customers per hour. We move on with the basic queuing system configuration for 99 SPEEDMART in Tapah, which is a multi-channel single phase. I will briefly explain this. Firstly, the customer will arrive and shop. Then, they will queue in the waiting line before paying at the counter. Customer will be served by the service facility, which is the cashier. In the 99 SPEEDMART, there are 2 counters. Customer can choose either one to pay for the groceries without needing to go to another counter. Lastly, the customer will exit the 99 SPEEDMART.
Alright, next we proceed with our utilization factors. So basically we have rho as our utilization factor. In the general formula we have lambda over server times mu as utilization factor. So in our calculation we inserting our lambda equal to 56, our mu equal to 34 and our server equal to 2. We will get 0.8235 as our utilization factor, and as it is probability we choose 2 decimal place, which is 0.82, which equal to 82% of the utilization factor. Alright, we proceed with the probability there is 0 customer in the system. So in general formula we use P null as the probability. So we calculation by inserting our lambda equal to 56, our mu equal to 34 and our server equal to 2. We will get 0.09679 as our result of the calculation. And since it is probability, we need to choose 2 decimal places and we round off the 7 to 6 and we get 0.097. Alright, next is the average number of customers in queue. So for our calculation, we choose LQ for the formula to calculate the average number of customers in queue. And after we inserting our value of rho, which is 0.8235, our P null equal to 0.09679, and our lambda equal to 56, and our mu equal to 34, and our server equal to 2, we will get 3.47 as our average number of customers. And then when we round off it's become 4 customers in our queue. Now we proceed with the average number of customers in the system. So basically we use general formula L, which is the LQ plus lambda over mu. So basically our LQ before is 3.47, and then we inserting our lambda equal to 56 and our mu equal to 34. We will get 5.1176. And then when we round off it's become 5.12, which is equal to 6 customers in the system. The next part is the average time customer spend in the system, which is mean the customer enter the premise until the time the customer done receiving the service by the cashier. So basically we have W as our formula, which is equal to L over lambda, and our L before is 5.1176, and then we just insert in this formula. And then for our lambda we have 56, and then when we calculate in hour we'll have 0.091, and then when we convert into the minutes we will get 5.48 minutes, which is mean it is the average time a customer spend in the system. Last but not least is the average time customer spend in waiting line. So basically waiting line here means the customer queuing in receiving the cashier service. So we have the formula of WQ equal to LQ over lambda. So basically our LQ before is 3.47 and our lambda equal to 56. When we divide both these value, and then we get 0.062 hours, which is quite hard for us to estimate what is 0.062 hours. So we convert it into minute, which is mean 3.72 minutes, which is it stands for 3.72 minutes a customer needs to queue until they got served by the cashier.
Conclusion. The number of servers provided is adequate as the time taken of the customer waiting in line to be served is shorter than the time taken they are in the system. Next, customers are happy as they do not need to wait for a longer time to be served by a server.
What we have learned. First, we have learned on how to describe the basic queuing system configuration. Second, if the average of service rate times the number of the server less than the average of arrival rate means that the queue will expand continuously. Third, if average service rate greater than average arrival rate, then the customer are served at a faster rate than they arrive.